Guys, we are getting ready to do Monday's notes, but keep in mind whenever you need to pause the video, please feel free to do so. And these are the notes that were in the PDF document that you should have downloaded before spring break. However, I'm sure most of you didn't. So if you don't have the notes, go ahead and download the PDF. If you can't print or figure out how to type into the PDF, then just write out the notes for yourself on a blank sheet of paper. Okay, here we go. Happy Monday. Okay, Monday's notes. All right, so we're talking about classifying a bunch of different numbers. And most of these numbers are familiar to you, but we're going to start off with natural numbers. So underneath your pyramid thing, I think it's on page like 4 or 5 of your notes, for those of you that have printed it, there's a little box where you're supposed to write the definitions. So under the pyramid looking thing looks like this, but underneath that, this is where you're going to write the definitions. Natural numbers, that's how you naturally count. So if we're playing hide and go seek, you're not going to start at 0 and then say 1. You're just going to count at 1. So natural numbers are counting numbers. 1, 2, 3, 4. And the mathy definition is all positive whole numbers. And then that brings us to whole numbers. So it's going to be all of the natural numbers and 0. So now we're going to include 0. So it's all positive whole numbers and 0. Because I guess technically you can have 0 wholes. And then that brings us down to integers. Integers, we've been talking a lot about those this year. All positive whole numbers, 0, and all negative whole numbers. So if you notice, we go from natural numbers, which are all positive whole numbers. Then we jump down to whole numbers, which are all positive whole numbers and 0. Now we're at integers, which are all positive whole numbers, 0, and now we're adding on all negative whole numbers. So we're adding a little something to the definition each time. And then we're looking at rational numbers. So rational numbers are all positive whole numbers, 0, all negative whole numbers, as well as all positive and negative fractions and decimal numbers that end or repeat. So what does that mean? Any fraction that you can think of is going to be rational. 5/10, 2/3, 1/2, all of those are rational. Any decimal number that you can think of is going to be rational. 2.4, 5.7. Even the weird ones where it's like 4.99999 repeating, as long as it repeats, it's rational. Because remember at the beginning of school, we talked about how a denominator of 9 makes things repeat. For example, 3/9 or 3/9 would be 0.333333 repeating. And that's a fraction and a decimal that repeats. So those are rational numbers. And then completely opposite of everything listed above is irrational numbers. Those are the super weird ones that we'll never solve. We can spend the rest of our lives trying to figure out the end of that number, and we'll never get there. What do I mean by that? So it's numbers that never end and never repeat. Most of you are familiar with pi, and we say that pi is 3.14, but that's just an estimate because that number goes on forever. Likewise, the square root of 10, which is that radical thing in 10, we kind of talked about it the week before spring break if you did your homework, but we'll never be able to figure out the square root of 10, or I guess the end of the number, because it's going to go on forever. And then every number that we just identified is known as a real number. So it's all numbers that we talk about in 8th grade, including irrational, rational, integer, whole, and natural numbers. So make sure you have these definitions. We're going to use these definitions now to complete our pyramid-looking thing. So at the very top of the pyramid, I've already typed it in, but it says natural numbers. So each time we move down a level, we're including another category of numbers. So natural numbers, remember, those are how you naturally count: 1, 2, 3, 4, 50, 60, a billion, 1,000, whatever you're going to count to. is going to be a natural number, a positive whole number, or natural numbers. Your whole numbers, now it's all the natural numbers, but now we're including 0. That's why that box or that section got a little bit bigger. And then we move down to integers. So now we're starting to include the negative whole numbers. So negative 2,345, negative 5, negative 3, whatever negative whole number you can think of, 0, and then whatever positive whole number you can think of is going to be an integer. 0, 1, 2, 3, 4. Also, 10/5. Why 10/5? That's a fraction. We said fractions are rational numbers. Well, because we can simplify 10/5, because 10 divided by 5 equals 2, and 2 is a positive whole number. So make sure that whenever you see problems like this, you're simplifying if you can. Okay, so we move on down from integers, which are positive and negative whole numbers and 0. We're moving down to rational numbers. So it's including even more numbers, which is why that section is getting even larger. So we've got all the numbers listed above. So the negative 2,345, negative 5, negative 3, 0, 1, 2, 3, 4, and so on and so forth. But now we're starting to include the fraction. So 2/5 is a fraction. 5.7, a decimal that ends. There's no number after the 7 there, so it ends. And then we've got the 4.9999999, a bunch of 9s. They're going to go on forever. Well, those repeat. So rational numbers are any number or decimals that end or repeat. So again, the decimal ends or repeats. Now, before we jump down to the next level, the very bottom level, because notice how that bottom level also includes rational numbers and irrational numbers. So let's look at irrational numbers before. These are the weird ones. So if you want, try and type that in your calculator. Who am I kidding? You don't have calculators at home. Ask Siri, or type it into your phone calculator, the square root of 45. It's going to give you a weird number. It's going to be a decimal number, 6 point something that goes on forever, and those digits behind the decimal never repeat and they never end. Same thing with the square root of 10. That's going to be 3 point something, and that something never ends or repeats. And then pi, which we again estimate as 3.14, but after that 4, it never ends and never repeats. And then we're going to jump down to the very bottom category, which was the real numbers. So that's encompassing all of the numbers above it. So that's including the rational numbers, the irrational numbers, the integers, the whole numbers, and the natural numbers. And those are all the different categories that we can identify a number as. So we got 1, 2, 3, 4, 5, 6 different categories. If you look down, I think it's on the next sheet, I don't know, but it's the next section. It says name all of the numbers to which each number belongs. So we're going to start at 30. So the best way to do this is think about 30 and then look at your pyramid. So how far up on the pyramid will 30 go? Well, of course it's a real number because all numbers are real. Is it a weird one? No, 30 is pretty normal. Integer, is it a positive or negative whole number? Yep, sure is. Is it a whole number? Yep, sure is. Is it a natural number? If you're counting, would you eventually count to 30? Yep. So that's where you're going to start. You're going to tell me that it's a natural number. Well, if it's a natural number, it's every single category under natural. So if it's natural, 30 is natural. 30 also must be a whole number. It's an integer. It's a rational number. And it's also real. So that's what I wrote here. So 30 is natural, whole, integer, rational, and real. Now, if we move down to the square root of 21, we can't solve that. We don't know how to solve that. So we're going to automatically say it's irrational. But then again, if it's irrational, it's a weird one, but it's also going to be real. So we started as far up on that pyramid that we could go, which is irrational, and underneath irrational is real. All right, so 6/3, well, let's simplify. 6 divided by 3 is 2. Well, how far up that pyramid can we go with 2? Well, 2 is going to be a natural number, so therefore it's natural, whole, integer, rational, real. And I'll let you look over these for a moment. -11. The furthest up we can go on that pyramid is integer. and then underneath integer is rational and then real. 0, the furthest up we can go on the pyramid, is whole. Underneath whole is integer and then rational and real. And then there's pi. We've been talking about pi. It's irrational, never ends, never repeats. And then it's also real. So everything in here is going to be real. And there's a decimal here, you just can't see it, but it's 5.333 repeating. Well, since it's repeating, it's going to be rational, and underneath rational is real. 5 4/7. Well, it's a fraction, but it's rational. And then underneath rational is real. The negative square root of 9. Well, that negative in front means that they want the negative answer of the square